Okay, Calc, this is section 6.1. We're going to get a little ways through this. This should take 2 days because it's a little bit longer, even though it's only a front and a back. This is the introduction to antiderivatives. And if you liked chapter 4 when we first learned what derivatives were, you're really going to like chapter 6. You really are. I'm not even lying to you, because antiderivatives are a lot of algebra stuff again, okay? So, yeah, antiderivatives, okay? Let me give you some information about antiderivatives, and let's kind of put like f of x over here in his little bubble. So this is the bubble of f of x, and this is like the original function, right? Okay, and let's say f of x lives there, and yeah, let's do that, okay? Let's talk about derivatives, because we know what those are, right? We take the derivative of a function, and the derivative of a function is f prime of x. That's the notation that we use, okay? For the derivative of f of x is f prime of x. That's how we do that, okay? Now, what they might do is, and what they will do, I guess, is they a lot of times will give us the derivative and they'll have us work back to the original equation. And to do that, we find the antiderivative, okay? Antiderivative, okay? This might be a little confusing to start with, but we can go back from one to the other by taking the derivative, taking the antiderivative, okay? Now, what happens if we're starting with the original and we're taking the antiderivative of that one? Antiderivative of the original function. They use the notation capital F of x to denote the derivative of an original function. So it goes capital F of x, lowercase f of x, and then f prime of x, okay? So if they give me capital F of x, which again is the antiderivative of some function, and I take the derivative of that, I get back to the original function, right? Okay, now this might make more sense if I do this. Let's do this. Let's call this guy the position function, okay? So if I'm dropping a rock, P-O-S-I-T-I-O-N. If I'm dropping a rock off of a like cliff or something, okay, a lot of times what will happen is you'll see something like y equals, let's say, negative 16 t squared, and let's just say plus 200. And what that's doing is that's saying, like, at a time of 1 second, you know, like it will be 184 feet in the air, you know, because I would plug 1 in there and that would tell me how high the function is, or how high the rock is. So that's my position function. If I take the derivative of that, that will give me the velocity, okay? And the velocity, because the velocity is like the derivative of a position function, so velocity, if I take the derivative of this thing, would be negative 32 t. That would be my, I will call that f prime of x. That's the derivative of that. And then, if I'm given that, I could take the derivative again and get to acceleration. Okay, and that's f double prime. So not f prime of x and not the original function in this case. We're taking the derivative twice and getting to f double prime of x in this case, and that's just negative 32. And this is like feet per second squared or whatever. We won't get bogged down with notation. There's that, right? Okay. So let's say by chance they give us acceleration and they want us to go back and find the velocity. Well, we can do that by doing the antiderivative, whereas we have never could before. Now, if they give me velocity, I can get back to the position function, okay? So we can go back and forth between things that we know and not just go straight derivative. Now we can go backwards as well when we know antiderivatives, okay? So this right here is kind of somewhat confusing. This means antiderivative, right? This is anti. And this guy means the derivative, right? So they're taking the derivative of the antiderivative and they're saying that's the same thing as the original function, which kind of is what we just illustrated up above. If I take the derivative of an antiderivative, I get to the original function. So just a lot of notational things going through here. One thing that I will say, they have some weird things that they do, and one thing that we have to make sure that we do when we are doing antiderivatives is including something called the constant of integration, okay? Circle that or box that or underline that or something and put plus c really big right over here, plus c, okay? You're going to learn how to do or learn what that plus c means like a lot, okay? So here's the deal. I'm going to go down to this example and I'm going to tell you what plus c means, okay? They're saying y prime is equal to 2. That means the derivative of something or of some function is equal to 2. The derivative of some function is 2, right? Like, okay, so I'm just thinking, not using any formulas for antiderivative because we don't know those yet, but I'm sitting here thinking, like, what would we take the derivative of and have it just give me 2, right? Okay, and if you think about it, let's just say 2x, right? Y equals 2x, and 2x is, if I take the derivative of 2x, that just gives me 2, right? So this is the antiderivative of 2, right? 2x is the antiderivative of just 2, because if I take the derivative, I get 2, right? And that's how I go back and forth. But the problem is that let's say instead of just saying y equals 2x, let's say I had y equals 2x plus 6. Well, what's the derivative of y equals 2x plus 6? It's just going to be 2 because the 6 actually crosses out to become 0, right? Well, what happens if I had y equals 2x minus 17, right? Well, what's the derivative of that going to be? It's still going to be 2 because the 17 crosses off to become 0. So we have a problem here in that the antiderivative of 2 is not just 2x, it's 2x plus 6 and minus 17 and any number that you want to tack on to the end of your 2x, because when you take the derivative, it will just end up being 2. So what we say is that the antiderivative of y equals 2, when I take the antiderivative, it actually becomes I'll say y prime equals 2. It actually becomes y equals 2x plus c, and c stands for a constant, and it's any constant. It's any number that you want to put in that spot, because when you take the derivative and go back this direction, when you take the derivative, that constant is just going to go away, right? Like the derivative of a constant is just 0. So when you tell me derivative or antiderivatives, you have to include that plus c on the end of there. And not today, but tomorrow we'll talk about like solving for that c and stuff like that, because they'll give us an exact point that we can plug in for y and x, and then we can solve for c exactly. But we won't do that yet today, okay? Now we'll just worry about derivatives or antiderivatives, okay? This is the notation that they will use when they are commanding you. This is the command. That is to say, find the antiderivative. This is the notation that they will use when they are commanding you to find the antiderivative. They'll say, this is an integral symbol. It looks like an S, kind of like really long. They'll say, find the antiderivative. That's what this says. Find antiderivative. I'm going to say of f of x. That's what this part says. And then they have a dx on the end, which looks kind of foreign to us. And I'm going to say with respect to x, because that's what dx means. You guys remember when we did like dy dx, and then it told us what variable we're taking the derivative with respect to, right? Like we would have dv dt. Well, that's when we're taking the derivative with respect to time. So this is just saying we're taking the antiderivative with respect to x, because that's my designated special variable. So this is just the command that is telling us find the antiderivative, and the antiderivative of such a thing. Remember, the antiderivative of lowercase f is capital F, and then we have to include that plus c on the end there. So this is kind of the notation that they will use. If that seems really confusing, it will get better later, because you'll just see that so often that it'll just become second nature. You'll just know what they're commanding you to do. But that's kind of the notation. That's what it means. Okay. All right, let's go to the back side and let's figure out some rules here. So I'll get through some of these. I'll get through like almost all of these, and then we'll do a couple of these examples down here together, and then we will stop, okay? I won't get through all of them because it just kind of takes a little bit of time, okay? So over here is differentiation. What does that mean? That is the derivative. Okay? Over here is integration. Integration is the wordage, I don't know, whatever, the stuff that they use for antiderivative. Okay, so integration and differentiation is saying derivative and antiderivative. Okay, so that's what that means. All right, so over here, get your derivative brain on, right? If I have a constant here, like 4, and I say find the derivative of 4, you get 0, right? So backwards, if they're saying this is commanding you to find the antiderivative of 0 with respect to x, and it's just going to give you a constant, like 4, right? The derivative of 4 gives me 0, so the antiderivative of 0 gives me a constant, such as 4, right? We would just write c, we would not put 4 in there because we don't know the specifically 4, but I'm just using that as an example. Like 4's derivative is 0, so 0's derivative is any number that you can think of, right? Even negatives. Okay, down here, let's talk about this. And this is saying k times x. I'm going to use the example of like 3 times x. And they're saying, what is the derivative of 3x? It's just that 3 in front, right? It's just the k that's in front, okay? So that's what the derivative looks like. 3x, his derivative is 3. So if I'm taking the antiderivative of that 3, what I can do is I can say, so this is kind of like the 2. What do I take the derivative of to get just 3? And that would be 3x, right? 3x, his derivative is 3. So if you're going back the other direction, it's 3x. But then we have to include that plus c on the end of there because it might be 3x plus 7, right? The derivative of 3x plus 7 is just 3, okay? Lots of confusing stuff. I hope I'm not going too fast. But anyway, so there's that, okay? Let's go down here to this next one, and let's say, I don't know if I want to do that yet. I don't want to talk about that one yet. I don't want to talk about that one yet. Let's go down to number 5. This is what's going to, yeah, I'm not going to talk about number 3 yet because that has like chain rule kind of looking things going on. So we're going to skip number 3. Just write skip next to it, and maybe we'll come back to that rule. You'll kind of see an illustration of that. Number 4, we are going to talk about, though, and this is saying like f of x plus g of x. This was like saying like x squared plus 2x, right? Let's go 3x. Let's go 7x. I don't know. We'll do something crazy so we're not using the same numbers. So when it's asking me to take the derivative of this, all I do is take the derivative of the first part. That would be like the f prime and whatever the g prime is, and I just put them side by side. So that would become 2x plus 7, right? That's kind of what my derivative would look like, okay? Over here, they're saying that when you are taking, like, I'm going to start with 2x plus 7, and we don't know the rule yet for finding the antiderivative of this, but what this number 4 is illustrating is that if I'm trying to find the antiderivative of this piece, what I can do is I can just break it into parts just like I did derivative. So I can find the antiderivative of 2x and I can find the antiderivative of 7, okay? And I can do kind of that process just individually, those pieces, just like we did with derivative, okay? We just look at this chunk, just look at this chunk. Same thing for antiderivative. Okay, here is the meat and potatoes, the part that you really, really, really need to remember, okay? When we're doing derivative, okay, if you have x to the nth power, like x to the 6th power, right, that n would come down in front, so 6 would come down in front. You would leave your x, and then you would subtract 1 from your exponent, and that would be 5, right? That's kind of what my derivative would look like. This is the formula that we use. Sometimes we don't even use a formula because that's just embedded into your brain that that's the way that it works, okay? This is the formula that you will need to memorize for antiderivative, and it looks really complicated, but you'll get so used to it that it's not even a big deal, okay? So let's start with 6x to the 5th power, all right? 6x to the 5th power, and this is the notation. This is them commanding me to find the antiderivative of 6x to the 5th power with respect to x, okay? So the rule is I do all of this stuff right here, okay? I do 1 over n plus 1. Oh, crap, what was n? Well, look here, n is your exponent, right? So I do n plus 1, that would be 5 plus 1. So I've just done this part of it, 1 over n plus 1, x to the n plus 1. Now, the problem is my x is not just x, it's actually 6x in this case. I'm going to put 6 there with the x. That's just going to kind of go as one piece. And then I do n plus 1 right here as the exponent rather than n minus 1 like we did over here. we do n plus 1. Now, n was that 5 again, so we do 5 plus 1. Okay, so what I have going on here, and then we don't forget our plus c, but 1 over 5 plus 1 is 1/6 times 6x to the, this guy is the 6th power. Okay, and then we simplify a little bit more. 1/6 of 6, those cancel each other out. So I just have x to the 6th power, and then don't forget the plus c, right? Okay, now I always go back if it's really easy like this and check my answer, because if I look at this and I take the derivative of x to the 6th power, that's 6x to the 5th, and the derivative of c is like plus 0, so it goes away. So I did it right. Everything is good to go. X to the 6th power, great. Okay, that's kind of that process, but this is what you will need to remember. 1 over n plus 1, x to the n plus 1. Okay, I'm going to go down here and we're going to do not 1, 2, 3, because those are really really ugly things going on right now. So let's just get the idea with number 4 and number 5. Okay, all right, so number 4, this kind of looks like it's not even a question, right? Like, what the heck is going on here? This is the command saying find the derivative of this thing right here with respect to x. But the problem is, what is this thing right here? Okay, it's not 0. If there's no number there, kind of like if there's no number in front of x, we assume it's 1. They're saying, what is the antiderivative of 1? Okay, well, I always just kind of think about this in my head, like as what would I take the derivative of to get 1? Okay, the derivative of 1x would end up being 1. But don't forget your plus c on the end there. The derivative of 1x plus c would be just 1. And this is my antiderivative. Okay, now I'm going to do that using the rule. 1 over n plus 1 x to the n plus 1. N plus 1. So the problem here is we don't have an x, right? But I'm gonna alter this thing to say 1x to the 0 power. That's essentially what is going on in here. Because if there's no x, it's x to the 0 power. Okay, so we're going to keep that in mind. And what's happening here is we're going to plug that stuff in. So here n is 0. I have 1 over 0 plus 1 x to the 0 plus 1. Okay, that's kind of like what I have going on there, right? I just plug my 0 in for my x and we're good to go, right? So 1 over 0 plus 1, this guy just comes out to be 1. And this is x to the 0 plus 1 is first power. And then don't forget your plus c on the end there. And that's exactly what we got here. But we did it using the rule, right? Okay. Number 5. So here's what I want you to do. Number 5. You don't have any homework for this section yet because we're not going to get done with the notes. But what I want you to do is I want you to try one of these 3 parts, maybe all 3 of them. If you want to try all 3 of them, try finding the antiderivative of all 3 of those parts. Pause the video so that you can do that. And then here in a second, I'm going to give you the solution to that. Okay, so do that right now. Pause the video, see what you can come up with for the antiderivative of this stuff, and I'll give you the answer. Okay? All right, don't cheat. All right, I'm going to give you the answer now. So, again, remember that we have 1 over n plus 1, x to the n plus 1. Okay? All right, so I have 1 over n is that 4, so I take 4 plus 1. Now, since there's a 3x here, though, I have to take the 3x in this spot, so I'm going to not just put x, I'm going to put 3x, because that's like the whole chunk there. And then I do n plus 1, which is 4 plus 1 to this guy, right? Okay, so here's how this works. 1 over 4 plus 1, this is 1/5 times 3x to the 5th power, which is kind of gross, okay? We're going to simplify that to 1/5 times 3 over 1 is 3/5 x to the 5th power. That's what we're going to go with, okay? So that's our first part. Now we got to do the other chunk, right? This guy. Minus 1 over n plus 1. N is 2. So we do 2 plus 1. But we can't just put x. We have to put 5x to the n plus 1, which is going to be 2 plus 1, right? Okay, let's simplify it down here. So this is negative 1/3 times 5x to the 3rd. If you haven't caught on yet, this denominator right here will always be the same as this exponent. This denominator will always be the same as this exponent, right? 3 and 3, 5 and 5. Oh man, there's some patterns going on here. you'll start to see that, okay? So if we do 5 over 1 times 1 over 3, this is minus 5/3 x to the third power, right? Just like that. And then we're doing this one, okay? This one, I'm running out of room over here. So we do 1 over n, which is 1. It's x to the first power, 1 plus 1, x to the 1 plus 1. So this is 1/2 x squared, which doesn't simplify any more than that. So we're just going to do plus 1/2 x squared. And then the last thing, don't forget, plus c. That is what we have, okay? All right, we're going to take the derivative real fast to see if we got it right. So if I take the derivative, I multiply the 5 down in front, right? 5 times 3/5, the 5s are going to cancel out. So I have 3x to the 4th power, okay? Minus, if I take this 3 and multiply it down in front, the 3's are going to cancel out. So I have 5x to the 2nd power, right? Same thing here. If I take 2 down in front, 2 times 1/2, or half of 2 is 1. These 2's are going to cancel out, so I have plus 1x to the 1st power. And then the derivative of c is just 0. This is what I have if I take the derivative, which is what I started with right here. So you can check your answer. Eliando, you're going to really like this section because you can check your answer. It's so exciting. And you know if you got it right, okay? So I just made a mess of it, but this is my antiderivative right here. Whew, lots of stuff. We'll go over this again. We probably will whip out some whiteboards in section 6.1 and 6.2, just doing these over and over and over and over and over again, so you get used to it, okay? These are going to be kind of ugly because they are fractional exponents, like x to the 1/2. So we'll get to that tomorrow. But there you go. That's all I have for you today.